Well then, look at this. I have an interference pattern. What is that interference pattern telling us? All right, well, that interference pattern is set up by this light shining through. I don't know if you can see it on the microscope slide, but I've blackened out a bit of the microscope slide right here so that you can see that it has a double slit on the microscope slide. You can't really see that, but all I've done with that microscope slide is take it so that I cut a double slit in it with two fine razor blades and shone a laser through that. That laser then going through that, hitting, making a interference pattern on it. Well, that tells us something about the essential nature of light. And that is the classic experiment that has shown us this. So in that experiment, which has been done repeatedly for hundreds of years, it shows that light must be a wave and could never be a particle. It's an important thing to recognize. In that experiment, you could see with your own eyes that light is a wave. Why? Well, because it shone through those two slits. If it was a particle and shone through the two slits, it would make a smear across the canvas, and it would simply be brighter in the middle and then dim as it goes through. How could you ever, if light is made of particles and you have particles shooting through both of them, like BBs shooting through both of them, how could you ever have it get a spot where there's no light there? That interference, where you have a cancellation of light, means that the crest of a wave must have met a trough of another wave. So those two waves coming out of the double slits have places where they interfere constructively and interfere destructively. That can only happen with waves. It would never happen with particles. Got it? That's the wave experiment showing, or the double slit experiment showing that light must be a wave. No two ways about it. Light is a wave, couldn't be a particle. Let's go to the next experiment.